This is the Morning Boot, daily tech news with the root access. Built for IT leaders, cloud engineers, security professionals, founders, and tech-curious listeners who want context, not hype. We cover what's happening in AI, cloud, security, and enterprise tech, and what it means for people running real systems. No fluff, just what shapes how we build, operate, secure, and scale. It is February 16th, 2026, 12:43 in California. Let's start with what matters. Everyone talks about the cybersecurity talent shortage, but what if the real problem isn't a lack of skilled people at all? The cybersecurity industry keeps blaming a talent gap, but the actual issue is something far more fixable: a leadership accountability gap. Consider this: the US Navy takes 18-year-olds with zero nuclear experience and trains them to operate nuclear reactors in just 18 months. They use structured programs, clear accountability, and intensive development. Meanwhile, security organizations post job listings demanding 10 years of experience for entry-level roles and refuse to invest in developing junior talent. Something doesn't add up there. Here's what's actually happening. Three compounding failures are destroying cybersecurity from the inside. First, shallow post-incident reviews that treat symptoms instead of addressing root causes. Teams run a post-mortem, patch the immediate issue, and move on without fixing the underlying structural problems. Second, unchecked technical debt that security leaders fail to translate into business risk language. Executives don't see the connection between outdated systems and potential breaches until it's too late. Third, promoting technical experts into management roles without any leadership training. You end up with brilliant engineers who have no idea how to build teams, mentor juniors, or drive organizational change. The surprising insight here is that talent is absolutely there to be developed if leaders take responsibility. The Navy proves structured development works. For security leaders, this means building clear career development programs that take people from novice to proficient systematically. It means performing rigorous incident analysis that goes beyond technical symptoms to organizational root causes, and it means treating technical debt like the business risk it actually is, quantifying it, mapping it to impact, and advocating for fixes. Here's a practical experiment worth trying. Next time you run a postmortem, include both technical and organizational root causes in your analysis. Then map identified technical debt to specific business impact metrics: customer churn risk, compliance exposure, operational downtime costs. Use those numbers to prioritize fixes and communicate the stakes to leadership in language they understand. If you keep treating recurring failures as inevitable, they'll keep recurring. Moving on. Modern product engineering teams are facing a battlefield most don't fully recognize: the software supply chain. Instead of building everything internally, teams now assemble applications from dozens or hundreds of third-party libraries, services, and CI/CD tools. This expanded surface is now a primary attack vector, not a background detail. Attacks like malicious dependency updates exploit blind trust in external code. A compromised library can silently inject backdoors, steal credentials, or exfiltrate customer data at massive scale before anyone notices. Real-world examples include the SolarWinds breach, where attackers compromised build pipelines to distribute malicious updates to thousands of organizations. The counterintuitive point is that supply chain risk isn't just an abstract security concern, it's a core product responsibility. Product teams must treat supply chain integrity as a top priority. This means using provenance tracking to know exactly where software comes from, cryptographic attestations to verify how it was built, and frameworks like SLSA, that's supply chain levels for software artifacts, to set and enforce standards. For IT leaders and product managers, this translates into embedding supply chain risk management directly into software development lifecycles and vendor assessments. It's not optional infrastructure anymore. Here's a practical experiment. Pilot a tool that verifies software provenance before deployment and correlates it with build metadata to detect anomalies. Test it on a non-critical service first, and measure how often you catch unexpected changes or dependencies. Once you see the gaps, you'll understand why this needs to be everywhere. Now let's talk encryption architecture. Coinbase has implemented something genuinely innovative with its core KMS encryption service using multi-party computation, or MPC. This offers a cutting-edge model for protecting personally identifiable information that solves a problem most organizations struggle with: balancing strong security with practical data access. Here's how it works. Core KMS uses MPC to derive ephemeral encryption keys on demand through distributed key generation. The critical detail is that no single party ever holds the complete master key. This dramatically reduces the risk from key compromise because there's no single point of failure. Then they use AES GCMSI for deterministic, authenticated field-level encryption of sensitive data like social security numbers. The surprising part is that this approach enables secure querying and indexing of encrypted records in systems like Snowflake without decrypting the underlying data. This breaks the usual trade-off. Most organizations assume strong cryptography means you can't query or index encrypted data efficiently, but Coinbase shows you can enforce strong cryptographic guarantees while supporting compliance-driven operations like state data match reporting. For enterprise architects and security teams, this suggests MPC-based key management can transform how you handle sensitive data at scale. Here's a practical experiment for listeners managing sensitive data workflows. Explore MPC libraries or cloud services in a test environment. Evaluate integration complexity, performance characteristics, and how well they fit your compliance requirements. Determined. The goal isn't to migrate everything overnight, but to understand whether this architecture could solve specific pain points around key management and encrypted data access. That's it for today's Morning Boot. Thanks for listening.